Right now, at this very moment, a NASA spacecraft is doing something that has never been done before in human history. The Europa Clipper, en route to Jupiter's icy moon, is flying directly through the ion tail of an interstellar visitor. Not a comet from our solar system, an object that traveled here from another star. And what scientists are discovering in these hours is rewriting everything they thought they knew about 3I Atlas. This is the story of the most dramatic 48 hours in interstellar astronomy, and why the internet cannot stop talking about what just happened. Let's rewind to Monday, October 28, 2025. That morning, the most watched podcast in the world dropped an episode that would ignite a firestorm. Joe Rogan sat down with Dr. Avi Loeb, the Harvard astrophysicist who has become either the most courageous scientist in astronomy or its most controversial figure, depending on who you ask. The topic was 3I Atlas, the Manhattan-sized interstellar object that had been racing toward the sun since its discovery in July. What Loeb revealed in that 3-hour conversation left Rogan visibly stunned and sent millions scrambling to understand what was actually happening in our solar system. Loeb didn't waste time with pleasantries. He opened with a statement that made headlines within hours. 3I Atlas had arrived from a direction in space aligned within 9 degrees of the famous WOW signal, the powerful and unexplained radio transmission detected in 1977 that remains one of astronomy's greatest mysteries. The probability of this alignment occurring by random chance, just 0.6%. Rogan leaned forward in his chair. "What the hell does that mean?" he asked. Loeb's answer was characteristically blunt. If 3I Atlas were transmitting a signal with the power output of a nuclear reactor on Earth, it would have produced exactly what astronomers detected as the WOW signal when the object was 3 light days from Earth. But the WOW signal connection was just the opening salvo. Loeb then laid out what he calls the anomaly stack, a series of observations that have earned 3I Atlas a rank of 4 out of 10 on his scale measuring potential technological origin. First, the object is massive beyond expectation, at least 1 million times more massive than Oumuamua, the first confirmed interstellar visitor in 2017. "We should have seen millions of Oumuamuas before we saw this one," Loeb explained to Rogan. "It's so big. There isn't enough rocky material in interstellar space to deliver such a giant rock into the inner solar system within a decade. You would expect it once per 10,000 years at best." Then came the chemistry bombshell that has divided the scientific community. Telescopes observing 3I Atlas detected nickel emissions but absolutely no iron. Rogan asked the obvious question: is it possible that nature could construct some sort of nickel alloy? Loeb's response was unequivocal. Nobody would argue that you could separate nickel from iron because they're produced together in exploding stars. The composition of the sun has 10 times more iron than nickel by mass. We just don't know how this is possible. The implication hung in the air. On Earth, nickel without iron appears in one place: advanced industrial processes, particularly in aerospace manufacturing. Loeb didn't stop there. He criticized what he called terrestrial stupidity, the bureaucratic failures that have prevented optimal scientific observation of 3I Atlas. The most transparent image of the object was captured on October 2nd when it passed, within 30 million kilometers of Mars. NASA's Mars Reconnaissance Orbiteur, equipped with the high-resolution high-rise camera, photographed the comet from a vantage point Earth-based telescopes could never achieve. Those images remain unreleased to the scientific community, due to what Loeb described as administrative roadblocks. "This isn't about alien origins," he told Rogan with frustration in his voice. "This is about transparency. We had a historic opportunity to study an interstellar object up close, and bureaucracy got in the way." The podcast dropped at a moment of maximum drama because of what was about to happen next. On October 29th, just hours after the Rogan interview went live, 3I Atlas reached perihelion, its closest approach to the sun, at 7:47 a.m. Eastern Time. Loeb had previously called this moment the acid test. If 3I Atlas were a natural comet held together by weak forces, The intense solar radiation of 770 watts per square meter at perihelion should break it apart into fragments that would evaporate rapidly, creating a brilliant display of gas and dust. If it were something else, something manufactured from stronger materials, it might remain intact. Or, as Loeb suggested in papers that raised eyebrows across academia, it might execute a maneuver. In astronautics, perihelion represents the optimal point for spacecraft to change velocity through what's called the Oberth effect. An engine burn at closest approach to the Sun maximizes the kinetic energy gained or lost from the maneuver. If 3I Atlas were an artificial probe, October 29th would be the ideal moment to alter course, deploy smaller craft, or transmit data using the Sun's gravity as an amplifier. The timing adds another layer to the mystery. Earth sits on the opposite side of the Sun during 3I Atlas's perihelion, making the object completely unobservable from our planet during this critical window. Coincidence? Loeb has calculated that this specific alignment has a probability of just 0.005%. For crucial hours, we were blind. Amateur astronomers and space enthusiasts watched helplessly as 3I Atlas disappeared behind the solar glare. But spacecraft weren't blind. NASA's GOES-19 weather satellite, which monitors the Sun for space weather events, kept its instruments locked on the comet. The polarimeter to unify the corona and heliosphere mission, PUNCH for short, tracked it continuously. So did the Solar and Heliospheric Observatory, SOHO, which has been watching the Sun since 1996. What these spacecraft revealed shocked astronomers when data started arriving. 3I Atlas got brighter, much brighter. Before disappearing from view in early October, the comet glowed at magnitude 11.5, requiring a decent telescope to observe. Predictions suggested it might brighten to magnitude 10 or 11 at perihelion. Instead, space-based observations indicated the object surged to magnitude 9, significantly brighter than anyone expected. Astronomers Chi-Cheng Zhang from Lowell Observatory and Carl Badams from the U.S. Naval Research Laboratory published their analysis on the Archive preprint server, noting the rapid brightness increase appeared driven by visible gas emissions. They predict 3I Atlas will emerge from behind the Sun in late November, considerably brighter than when it entered. This brightness anomaly raises uncomfortable questions. Natural comets do brighten as they approach the Sun due to increased outgassing from solar heating. But 3I Atlas has already demonstrated unusual behavior in this regard. Earlier observations showed it losing water at a rate of 40 kilograms per second when it was nearly 3 times farther from the Sun than Earth, a distance where most comets remain relatively quiet. The James Webb Space Telescope detected an unusually high ratio of carbon dioxide to water vapor, suggesting formation conditions radically different from anything in our solar system. Now it's brightening faster than models predict. Is this exotic chemistry from another star system producing unexpected reactions? Or is something else happening? Enter NASA's official statement, released on Wednesday, October 30th. After months of observations and analysis, the space agency formally classified 3I Atlas as a comet. The announcement emphasized that scientists observed clear signs of cometary activity, an icy core, a luminous coma of gas and dust, and spectroscopic evidence of water vapor, carbon dioxide, and other volatiles. The message seemed designed to counter speculation about alien technology. 3I Atlas displays classical signatures of cometary activity. The statement read, "Case closed, right?" Not quite. The NASA announcement coincided with another development. The ongoing government shutdown that began October 1st has prevented data sharing from any NASA missions observing the comet since that date. The Mars Reconnaissance Orbiter images remain locked behind administrative barriers. The Perseverance rover on Mars captured images of 3I Atlas on October 3rd, showing what appeared to some observers as a cylindrical shape. Though experienced astrophotographers quickly identified classic star trails from the long exposure. Those images are public, but higher resolution data is not. The Europa Clipper, currently passing through the comet's ion tail, is collecting unprecedented measurements. When will that data be released? February 2026 at the earliest, due to thermal constraints on the spacecraft's communication systems. This brings us to right now. From October 30th through November 6th, the Europa Clipper spacecraft is potentially immersed in the ion tail of 3I Atlas. This represents the first time in history that a spacecraft has flown through the tail of an interstellar comet. The mission's particle sensors and spectrometers are designed to study Jupiter's radiation environment, but they should detect the signatures of 3I Atlas's ion trail. What they find could reveal the comet's composition in unprecedented detail. Is the nickel-to-iron ratio really as anomalous up close as it appears from a distance? Are there other unexpected elements present? We won't know for months. The European Space Agency's JUICE spacecraft, also en route to Jupiter, will attempt observations of 3I Atlas in early November, when it passes within 64 million kilometers of the comet. Unlike NASA missions currently hamstrung by the government shutdown, ESA isn't affected by American politics. JUICE's cameras, spectrometers, and particle sensors will provide fresh data from a different perspective. ESA's ExoMars Trace Gas Orbiter already captured images of 3I Atlas from Mars orbit in early October, showing a fuzzy white dot with hints of a tail. The November observations should be more revealing as the comet remains active. Back on Earth, ground-based telescopes wait for 3I Atlas to emerge from the sun's glare in late November. The International Asteroid Warning Network has announced a coordinated observation campaign running from November 27, 2025, through January 27, 2026. This global effort aims to extract precise astrometric measurements and monitor any changes in the comet's trajectory, brightness, or outgassing behavior. The campaign directly follows a white paper Loeb submitted to the United Nations in September, advocating for international coordination in monitoring interstellar objects that could pose technological threats. While most astronomers view this as standard scientific collaboration, others see it as validation that authorities are taking Loeb's concerns seriously. The comet will make its closest approach to Earth on December 19th, coming within 269 million kilometers, about 1.8 times the Earth-Sun distance. It poses absolutely no threat to our planet, but by then we should know much more about its nature. Will it maintain its unexpected brightness? Will astronomers detect any changes in velocity that cannot be explained by outgassing? Will new spectroscopic data resolve the nickel-iron puzzle? These questions will be answered in the coming weeks. Loeb maintains his position that 3I Atlas is most likely a natural comet with unusual properties. His rank of 4 out of 10 on the Loeb scale explicitly means probably natural but anomalous enough to warrant serious investigation. The 8 anomalies he's documented, from trajectory alignment to chemical composition to timing, each have probabilities ranging from 0.005% to 0.6%. Multiply those probabilities together, and you get odds so astronomical that Loeb argues we cannot simply assume a natural explanation without extraordinary evidence. His critics counter that rare events do happen. The universe is vast. Given enough time and enough space, even 1 in a million coincidences become inevitable. The nickel-iron anomaly might result from chemistry we don't yet understand in extreme environments. The trajectory alignment might be selection bias. We discover objects on certain paths more easily than others. The brightness increase might fit cometary models better once we have complete data. NASA's official classification as a comet represents the consensus view of the astronomical community. Yet, even NASA's statement acknowledged that 3I Atlas is scientifically valuable precisely because it differs from solar system comets. Every measurement reveals information about the molecular cloud that birthed this object 7 billion years ago in some distant stellar system. Whether it's carrying alien technology or not, it's carrying something just as precious: direct physical samples from another star's planetary formation process. We've never had this opportunity before. In March 2026, 3I Atlas will pass near Jupiter at 50 million kilometers before departing our solar system forever. This is our only chance to study it. The last 48 hours have given us a Joe Rogan podcast watched by millions, NASA's official classification, the unexpected brightness surge, and a spacecraft flying through an interstellar comet's tail for the first time in human history. What the next 48 days bring may determine whether 3i Atlas becomes a footnote in astronomy textbooks or the most important discovery of our lifetimes. As Loeb said to Rogan with characteristic directness, if there's even a 1% chance that 3i Atlas is not natural, we owe it to ourselves to look closer. Science is better than fiction because nature might be more imaginative than the best scriptwriters in Hollywood. The acid test has begun, and the universe is watching to see if we're paying attention.